I'll use these example responses from the Quantum Random Number Generator web service. The query string is formed by appending the question mark for the query string. You indicate the number of random values that you want and then the data type. Let's open up the JSON file that's returned. We have key value pairs. One is a string, one is an integer, one is an array of integers, and another one is a Boolean. So we're going to have different data types. And I've captured that into this string constant here. This is a second example for 16-bit integers, and the third example illustrates what happens when some of the JSON string is different than expected. Let's look under string, flatten, unflatten, and then find unflatten from JSON. Let's take a look at the context help in order to examine the input-output terminals. Two primary inputs are the JSON string itself and then a cluster that defines the types and the default values for the keys. The output then is another cluster. Let's try the first example, and then we need to create a cluster constant to match each of the keys: type, length, data, and success. Do a cluster constant. The first one is a string. Place a string constant and then give it the name of the key. So we'll make the label visible and then match that up with the key, which is type. Again, those need to agree. That tells the JSON unflattener what to look for. Let's go ahead and create an indicator so we can watch what happens on the output side. Go ahead and run that, and it has successfully extracted uint8 as a string, which is the value for the key type. Length is an integer. I'm going to begin by placing a double. Let's give this the name length. And length is never a fractional value. It's the number of elements that's returned. Let's change that to the typical integer for LabVIEW applications, and that would be I32. Each time I add a different cluster on the input, I have to change the output. All right. Let me also illustrate how you can pull out individual values from that cluster. Do unbundle by name. Therefore, with this technique, we simply recover the value of length. Data is an array of integers. So I add a little bit of space here. Let's create an array constant. Let's fill that with a data type that matches what we are given, which is an 8-bit integer. Place the integer and then change the representation to unsigned 8-bit integer. This needs the label data, and then place that in the cluster constant. All right, one more to go. Success is either true or false, and that's a Boolean. Let's create a Boolean constant for that. All right, I'll create a new cluster indicator. And let's expand this to pull out the value of success and make a front panel indicator for that. Let's give it a run and see how we're doing. To see the remainder of the array, let's expand that down to show all 10 values. All right, let's try the second JSON string example and see how that works out for us. Numeric value is out of range of the LabVIEW numeric data type. We need to promote this one from unsigned 8-bit integer to unsigned 16-bit integer. All right, there's our 4 elements, or 5 elements rather. Looks good. And let's try the third one. Cluster element was not found in the JSON string. This will require a little bit extra work to deal with the fact that sometimes the key value pairs might be missing. I'm going to begin by making a copy of this cluster constant and then delete the 3 that are missing. Okay, we see that success is indeed false for this case. If we try another one, success is true. Looks like we can use the success value as an indicator as to whether or not we can find the other 3 key value pairs. I'll point out that with strict validation, then it's not going to work. It always has to see exactly what you specify in the cluster constant. With the default, however, it only looks for key value pairs that you have specified in that cluster constant. Give a little more space here. Let's use a case structure that's selected based on that success value. And the idea being that we only look for the remaining elements if we know that the success value is in fact true. So we'll have 2 calls to the unflattened JSON string. Let's place the cluster indicator outside of the case structure. And I'll show you a couple different ways of creating a default cluster output for the false subdiagram. One would be to create the default constant. The other one would be to say use default if unwired for that tunnel. And I've gone ahead and run that. Everything looks good. Let's try the version for our second example. Also looks good. And then just to test this to make sure it's working properly, on our third example, we see success is false and all of the data elements then are either 0 or empty.